This is Geometry, Semester 2. It's a unit called Area and Perimeter. It's the 9th unit, and it's review, so Area and Perimeter review. It's the second lesson within that review called Trapezoids, Parallelograms, Irregular Shapes Practice. It's on creatormath.com under the Geometry tab. Copy the following problems into your composition book on the correct pages according to the table of contents with the notes for those pages from creatormath.com. So before we go to our first problem, let's just quickly review. Here's a website name, creatormath.weebly.com. You probably have to type into Google to find it. The home page should look like this. Once you're there, you go into the Geometry tab, pass by the vocabulary stuff. Make sure you're in Semester 2, Table of Contents. This should be written on pages 2 through 6 of your composition book. Scroll down to the 9th unit. So this one right here, Area and Perimeter Review. Here's the first lesson that we're on right now. No, we're going to do the second right now, Area and Perimeter of Trapezoids and Parallelograms. Match up the title. The notes will be there when you go to see this. You'll be able to click notes, put those on the right pages of your comp book. This is way up on page 159, 160. There'll also be the video link here for you to watch this video. Right? That's how you find it. So this is Area and Perimeter Review. We're assuming we've already been through this content before. We're reviewing it, and we're going back through and trying to just refresh our memories. So given a parallelogram, it says right here, if the base is 10, each side length is 7, and the perpendicular height is 5, what is the area? So, and it looks like in this case, it's not just area, it's what is the area and perimeter. Okay, what is the area and perimeter? So, let's label what they say. The base, this equals 10 down here, and if this is 10, and it's a parallelogram, then I know that this side is 10. Then they tell us each side length is 7, so this is 7 and 7. Then they tell us that the perpendicular height, and that's this right here, so notice the 90 degrees, the height is 5. So area of a parallelogram is just base times perpendicular height. Height, try to abbreviate that a little, and this should be a B, a base. So area equals the base of 10 times the perpendicular height of 5. And there's two units on this one, units on this one, so the units multiply to be units squared, and that's good because it's an area, right? So what we have here is 10 times 5 is 50. We have 50 units squared, because it would be units times units, u times u, and this would be 50 units squared. The perimeter is just the distance around the shape, so let's start here. Actually, I'm going to go, this distance would be 10, plus 7 is 17, plus another 10 is 27, plus another 7 is 4 to make 34. So I'm good with 34. Notice this is units to the 1 power because it's a length, units squared because it's an area. Given a trapezoid, if base 1 is 20, so let's call this 20, and base 2 is 10, it looks shorter, so we can say base 1 is 20, base 2 is 10. One side is 7, let's make this 7. The other side is 9, let's make this 9. And the perpendicular height is 5. Perpendicular because it's 90 degrees. What's the area and perimeter? So that's nice. They ask us that here, area and perimeter. Well, it tells us, hint, the area formula for a trapezoid is area equals 1/2 base 1 plus base 2 times perpendicular height. Height. And so base 1 and so what this does, base 1 and base 2 added and divided by 2, that's an average of the two bases. So we take 20 plus 10 divided by 2, and that's going to be 30 divided by 2. I'm going to move ahead here and say 15. The perpendicular height is 5, so let's multiply this by 5. That's 50 plus 25 is 75. So equals 75. This is units squared because it's a area, and that would be units right here, units, and units here. Units times units is units to the power 2. So 75 units squared. We know it's this answer. Let's check perimeter. If we go 20 and 10, those are two distances, right? That's 30. This would be 39 if you add it in, and this would be 46. So I like this right here too. Check and check. Units match up with me. Check, check. Remember, my answer is in the position A. On yours, it's going to be randomized, so you're going to have to find that. Given the parallelogram, which with side length 5 centimeters and 10 centimeters. So I'm assuming this is 5 centimeters, this is 5 centimeters, this is 10 centimeters, and this is 10 centimeters. And a perpendicular height right here of 4. They don't say centimeters, but let's assume it is. What is the area and perimeter? So area is just base times height, and it's perpendicular height. So area equals base times perp height. The big mislead is students want to call this height 5 centimeters, but because it's at an angle like that, that is not the height. We need the perpendicular height, which is 90 degrees to the base, right here. H equals, in case you can't see it. So we need base is 10, so area equals, well, let's keep the units in, which I would have liked to have done on the others now that I think about it, times the perpendicular height is 4 centimeters. Area equals 4 times 10 equals 40. Centimeter times centimeter is centimeter squared. 40 centimeters squared. I like the area. I like the units. Let's just check for perimeter is 10, 15, 25, 30. 30, and it's centimeters only because it's a length for perimeter. Given the following graphic, what is the area? So this looks like a parallelogram, right? Looks like base. We're using the Cartesian coordinate plane to help us find this. This is x comma y. This must be the origin because it's 0, 0. Looks like we got 9 on the x. So this is 9 long. If it's a parallelogram, this will be 9 also. We're going from x value of 2 out to 11. 11 minus 2 makes this 9 also. So that's 9 long. So that's good. That matches up with a parallelogram. And I would have liked for them to have told me that, but because my height here on the y is a 5 here and here, that confirms to me that this length must be the same as this length, right? So I'm very assured that this is a parallelogram. It says base times perpendicular height. What is the perpendicular height here? Well, since we're up 5 on the y, 5 is the perpendicular height. So area equals base times perpendicular height. 9 times 5 equals 45 units squared. Not too bad. Given a trapezoid with 2 bases, measuring 10 and 6, if this is 10, this is 6, side lengths of 4 and 7, and a perpendicular height equal to 3, what is the area and perimeter? Area equals, they tell us right here, 1/2 the 2 bases averaged, well, 1/2 of the 2 bases is the average of the 2 bases. It's 1/2 of the 2 bases added times the perpendicular height, and I would have rather they said perpendicular height right here. Right, because students are oftentimes confused. They see this 7 and they go, that must be the height. Nope, we need the perpendicular height. So let's see what we got. We got 1/2, base 1 is 10 plus 6, times perpendicular height of 3. There are units here, and there are units here. So 16 divided by 2 is 8, times 3, units times units is units squared. Area equals 24 units squared. And sure enough, that's this one. Let's check the perimeter to make sure. 10, 14, 20, 27. Check, 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 check. We've got the values and their units, and those seem appropriate. Given an isosceles trapezoid with 2 bases, 11 and 13, so let's make this one 11 and this 13. I'm just going to pair it up with the diagram. The diagram could be drawn this way, right? And then it might be easier for us to go ahead and say 13, 11. Not going to matter. You can flip a trapezoid up and down. That's why I asked my geometry teacher in high school, why do they call them bases if one's up top and one's on the bottom? Well, because you can flip the shape, and now the one on top is on the bottom. So we just call them both bases. Morning, Angeline. Okay, so what's the area? Hint, the area for a trapezoid is 1/2 base 1 plus base 2 times perpendicular height. Area equals 1/2 the 2 bases, base 1 plus base 2 times perp height. Area equals 1/2 times the 2 bases are 13 plus 11. Let's see what else. I didn't put in the rest of the information. Side lengths are 8. It's isosceles, so this is 8 and 8. Isosceles means two sides equal length. Height, perpendicular height, is 5. So we're going to go times 5. There's units here, and there's units here. Area equals, this is 24 divided by 2 is 12, times 5 is 60, and units times units is units squared. Let's add up the perimeter. 13 and 8 would be 21, 22, 32, 40. Nice. So 40 feet, and notice feet is a length, so it's to the power 1. And our 60 feet squared is an area, so it's to the power 2. All right, given a rhombus, if the base is 10, so here's a 10, it's a rhombus. Each side length is 10, and the perpendicular height is 5 square root of 3. So since it's a rhombus is a pushed over square. So all sides will be 10 long. So I already know what the perimeter is, 10, 20, 30, 40. So I like this answer, right? So I'm already on track with this. I could have figured it out with perimeter. Let's take a look at this, though. The perpendicular height is 5 times the square root of 3 feet. So 5 times the square root of 3, units are feet. Why is that 5 square root of 3? Well, this one's kind of interesting. If I could just go back, I know you've already covered special right triangles because this is a review section. Let's say this was 30 degrees. That would make this x. That would make this 2x, and this x radical 3, if I'm remembering my special rights correctly. So it looks like what they've done is they lined up the hypotenuse of this right triangle with the side of the rhombus. So here's the rhombus. Here's the side in question. We want to know the perpendicular height. Assuming this angle is 30 degrees here, this would be 60 degrees here. It's a 30, 60, 90 special right triangle. If this side is 10, we take the 2x, put it equal to 10, solve for x, and go back and see your special rights to figure this out. We're going to do it quickly here. X is 5. That would make this length 5, but it would make this length, x is 5 times square root of 3. So that looks like exactly what they're doing to calculate the perpendicular height of this, and that's kind of cool. So let's take area. Area is base times height times perpendicular height. Height. Kind of go like this to separate everything out. Base is 10 times perpendicular height is 5 radical 3. This is units. In this case, feet. This is feet times feet. 10 times 5 equals 50. The radical 3 just stays radical 3. And feet times feet is feet squared. Sorry for the mess there, you guys. But 50 radical 3 feet squared looks good. I'm good with this on perimeter basis and on area basis. Let's see here. What word do we use to measure the height of an airplane flying in the sky? More than one answer may apply. So this is my version of an airplane right here. Sorry, you guys. It's supposed to be the tail. This is supposed to be the wing. Hope it kind of looks like an airplane. Here's the ground. If you want to say how high an airplane is, we use this thing called altitude. Altitude is what we call the perpendicular height. So altitude, perpendicular height, this is just an illustration of when you're trying to figure out the height of a triangle. Is it this length? Is it this length? No. It is the perpendicular height, 90 degrees. It's this distance. Ding, ding. This is the height of a triangle. And what are we focusing in on? We're focusing in on a perpendicular height. And imagine an airplane over here, right? The airplane's far away from you, and I really can't draw it now, right? There's the airplane with its propeller on it. All right, and a wing back there. We don't measure the the height of the airplane by going the distance to the airplane. That would be a completely different measurement. We measure the height of the airplane by a perpendicular height, or also called altitude. That's the point of this whole thing. Given a kite with minor diagonal 10, minor diagonal, smaller one, 10, and major diagonal 25, major 25. What is the area? So they tell us that area of a kite, K-I-T-E, area of a kite, K-I-T-E, is 1/2 diagonal times diagonal. So area equals 1/2. Diagonal 1 is 10. Do they give us a unit? Well, 10 units times 25 units. is 250 units divided by 2. A equals 125 units squared. Remember that we multiply units times units to get units to the power 2. 125 units to the power 2. More? Oh boy, keeps going. All right, irregular shapes. Given the following irregular shape, what's the area? Well, the key to a complicated shape like this is to break it into simple shapes we know how to calculate. So let's divide it right here. Notice I've got a little tiny triangle, rectangle, and its dimensions are 1 and 2. So the area of that thing is 1 times 2 equal to 2, and it's units squared because it's units times units. Then we have this larger rectangle. It's shaded a different angle there, and it's 5 times 7. So area equals 5 times 7, base times height, which equals 35 units squared. And we want to combine those two to get the overall area, right? So 35 and 2 should be 37 units squared if I did it right. Did I do it right? 1 times 2. And, I see a problem here. You know, the fact that they made this side 5, and this is a little unclear, and I would have rather they clarify this, but look, if this is 5, then the actual length of this one is not 5. It's 5 minus this 1 makes this 4. So this should be 4 times 7 is 28. 28 plus 2 is 30. So that's a little unclear, and I'm not so happy about that. At the same time, I probably could have figured that out if I looked a little bit closer when I started. Right? So, vague problems can be annoying, but sometimes that's a lot like life, right? Most of life is vague. Given the following graphic, if r equals 6, maybe not, maybe I'm wrong on that, and base 1 is 10 and base 2 is 16, what is the area of the shape? So here, see how they did this? They gave us actual measurement with tick marks. I now know that base 2 is 16. Base 1 is 10. So this is nice because it's unambiguous. It's clear to me. I know that these links are from here to here. All right, here to here. Then it looks like we have a radius, a hemisphere here. Half a circle is a hemisphere, r of 6. So I would argue we have some different shapes here. We have a half a circle. We have a what looks like rectangle here. And we have a triangle here. We have these 3 shapes. So we're breaking this complicated shape into 3 shapes. We're going to find the area of each, add it up, and see if we can come up with the total area of this irregular shape. So area of a circle is pi r squared. We have half a circle. So in our case, 1/2 of area is going to equal 1/2 pi r squared. This equals 1/2 pi, r is 6 squared, and that would be units squared also. So this is going to be 36 divided by 2. This is going to be 18 pi units squared. All right, let's do this one. This is 10, and if radius is 6, then a diameter would be 12. So this has got to be 12 high. So it's going to be area equals base times height, which equals 10 times 12. 10 units times 12 units. So area of the rectangle equals 120 units squared. Units times units is units squared. The area of a triangle is area equals 1/2 base times height. So this equals 1/2. The base of this thing is 16 minus 10 has got to be 6, and the height's 12. So 1/2 6 times 12. 6 times 12 is 72, divided by 2 must be 36. So area equals 36 units squared. Why? Because it's units times units is units squared. So it looks like I have 120 and 36. That could add up to 156. And this is 18 pi. I can't add 18 pi to other things that don't have a pi on it. So it's going to stay separate. So it looks like I have 156 units squared plus 18 pi units squared. So 156 plus 18 pi, and it might have had a parentheses to show the unit squared is on both of these. All right, would have liked that. And let's do one more. Given the following irregular shape, what's the area? Well, we're going to break it into smaller rectangles. How about this? There's one. There's one. Here's one. Here's one. And then we got this long middle rectangle here. Now, can we figure out all the dimensions? Let's take this one. A 1 and a 3. So area equals 1 times 3 is 3. Do they tell us units? Units squared. All right, let's take this one. 2 times 3 looks like. 2 times 3. Area equals 6 units squared. Let's take this one. 4 times 3. So 4 by 3. So area equals 4 by 3 is 12 units squared. 12 units squared. 4 times 3. This one here looks like a 4 and a 3. So area equals, again, 12 units squared. Then we have this middle piece. This middle piece is too wide. So let's draw that. Too wide. And how tall is this? Well, this is 2. This is 1. That's 3. This is 4. That's 7. And this is 3. That's 10. So I think it's 10 high. So area equals 2 times 10 is 20 units squared. So can I add all these up? 20, 32, 44, 50, 53. I get 53 units squared. That one's kind of difficult, but oh man, this one keeps going. All right, let's do another one. Following this is problem 13. This looks like, is this a quarter circle maybe? What's radius? Radius is 4 units. 4, 4 would be, it looks like a quarter circle. Then it looks like we have a rectangle. The base 1 is 8 units, 8. The base 2 is 16. This whole thing is 16. So you got to subtract 4 would be 12, would be this length. I hope they give us more information here. Radius of 4, base of 16. This is 4 high. We've got that. Oh, duh. 16 minus 8 is 8. Minus 4 leaves you with 4. This has got to be 4 here. So if you add up 4, 8, and 4, you need to get back to the total length of 16. All right? So this might take a second or two, right? And you see me too. I'm modeling for you the way you've got to go through it also. Here's a quarter circle. 1/4 of the area of the circle is 1/4 pi r squared. Rectangle of 4 by 8 and a triangle of 4 and 4. So this equals 1/4 pi. What is r? R is 4 squared. So 4 squared is 16 divided by 4 is back to 4 pi. 4 pi units squared. Area here is equal to base times height, which is 32 units squared. Area of a triangle is equal to 1/2 base times height, which equals 1/2. 4 times 4. All right, 16 divided by 2 equals 8 units squared. So 8 and 32 looks like 40 units squared. I can't add it to this. It's 40 units squared plus 4 pi. Hey. And I would have preferred a parentheses here to show that the unit squared is on this total amount here, right? Given the following graphic, A is 10. This is 10. C is 4. D is 8. This length here. E is 8. So let's label it first, you guys. F is 4. This is 4 here. What's the base area? Oh, 10 minus 8 would leave this at 2. The height of this thing, of this triangle right here, is going to be 8 high here plus 4 here. So this is going to be 12. Let's break this into 2 rectangles. So let's take this rectangle here and go 4 times 8. This equals 32 units squared. I'm going to cut some corners here because I'm running out of time. This one is 12 high by 2. 12 high by 2. equals 24 units squared. And this triangle is 12 by 4. So equals 1/2 12 times 4. 12 times 4 is 48, divided by 2 is 24 units squared, because it's 1/2 base times height. Okay, these are both b times h for area equals. All right, so what do we have? We have 24 and 24 is 48, 70, 80, 80 units squared. All right. Let's this. Why are the units for perimeter raised to the power 1? Because it's one-dimensional. So perimeter is a length. A length is just from here to here. There's no two dimensions. There's only one dimension, so it's units to the power 1. It's one-dimensional. And why are units raised to the power 2 for area? Because it's two-dimensional. Take, for example, this shape. Now you have an x dimension and a y, a horizontal and a vertical. By the time we multiply an h by a v, it's a unit times a unit, and we end up with units to the power 2. Two-dimensional. What are the and if you can imagine, just take it one step further, what should be the units of a three-dimensional shape? It should be units to the power 3. It should be everything's one dimension, two dimension, three dimension. What are the common three dimensions used? Length, width, and height, horizontal, vertical, and depth. More than one may apply. So here's a three-dimension, right? Horizontal, call it x, right? That's your x-axis. Vertical, call it y-axis, right? Which is exactly what we call it. And this one here, they often call this a z-axis, but also depth. Okay, so horizontal, vertical, and depth. Three dimensions would be length, width, height, horizontal, vertical, depth. Either one's acceptable. So, sorry for the long set of problems on this one, longer than I would have liked. Make sure you're matching up geometry, semester 2. The unit on area and perimeter review, it's number 9. And the lesson number 2 on trapezoids, parallelograms, and irregular shapes. It's on creatormath.com or creatormath.weebly.com under the geometry tab. Okay, hope this helps.